All right, so the big hint that a problem is going to be one that is going to be one of those complicated, like negative mc delta T equals mc delta T, is if you have three temperatures. One of the temperatures, the equilibrium, and the other two temperatures are going to be related to that. So if you look at this problem, I see three temperatures. So I would personally work on this one last, because if I spend like all my time on this one question, then I'm losing out on the time I would be able to spend on a different question, maybe 5 or 6 different questions. But I'm going to go ahead and work it. I'm just saying that's what I would do. So it's going to be this right here. I need to make sure I put the negative number with my higher temperature. So negative 35.7 grams times, it gives me lead a little bit further down, 0.128 joules per gram degrees Celsius, times delta T, so that's T final, which is the equilibrium temperature, minus T initial, which was that 95.1. So that is this side here. And then I need to set it equal to the water side. So what's the mass of the water? I'm solving for M. And then I know that's 4.184 joules per gram Celsius. And then this temperature is still that same equilibrium temperature minus the 22.1. And the big thing on this one is that you also could have rearranged it for this by dividing both sides by the C of water and then that of water. Got rid of that one. So anyways, I'm going to put this in my calculator and see what I get. Negative 35.7 times 0.128 times parentheses 27.6 minus 95.1. So I got that whole range right there. And then divided by, because that's what this essentially is I'm dividing by this on this side. 4.184, and then divided by 27.6 minus 22.1. So that gives me a negative mass. And so if I look up, I have a typo in my equation right there. It's supposed to be right there. And then that gives me my answer, which is 13.4. And the problem says to round it to 2 sig figs. So there you go.